Welcome, welcome, everyone. Thank you for being here. Good to see so many smiling faces. I recognize some people here. Welcome. Hey, Ryan. All right.
Hey, Matt.
Hey, everybody. Thank you for being here. Thank you for taking the time. I appreciate you all. All right. We're going to begin here in just a second. Rich, would you mind being co-host here? You're the best. Everybody thank Rich for letting folks in so I can just start. All right. Well, I am just so grateful that you all are here. It's a beautiful day outside. Maybe it's a beautiful day out where you are. So I'm going to make this matter. I'm going to make this valuable because I know a beautiful day like this. It's hard to compete. So I want to make sure that I deliver. So here we go. We're going to begin. This is a pretty exciting presentation I've got for you guys. Um, I've been thinking about how to serve you guys at that higher level, and I think I've got it today for you. So thank you for being here. We're talking about solving problems with soil microscopy. And many of us know about a problem that we're facing. Many of us know about the obstacles we're facing. Maybe it's on your farm. Maybe it's about soil in general. Maybe it's about topsoil loss. Maybe it's about nutrient deficiency. Maybe it's about biological deficiency. We may know about these problems. And microscopy is a powerful way to find those solutions, verify those solutions, and make sure those solutions are still solving those problems. Because things can change over time. And I want you to know that things are more possible than you probably know right now. There's more. And maybe you sense that. You know that there's more. You at least know that there's more that you can do to solve some of these problems, right? I bet if you took a moment right now to think about the things that you know you should be doing with your soil and your plants that you haven't quite gotten to implement, you haven't quite gotten to invest in, but you know it would help you. You know it would help the bottom line. You know it will affect how things change. And I just want you to honor that part of yourself and look at that straight on and be like, I do know that I need to do those things. I'm not doing them. And ask yourself why. Because the reality is, with microscopy, all those solutions, whether you're like, well, I want to do mycorrhizal fungi. Oh, I want to do endophytes. I want to do, ecologically complete compost, whatever it is. I'm telling you, it's easier than you think. And it's more powerful than you think. So, the number one most consistent thing I see when people really go into this space, when people really put the pedal to the metal, they see things that they couldn't believe or expect or predict. And that's really, one of the power and promises of this space. So let's start off. So what if all soil science is predicated on a fundamental inaccuracy? Wouldn't that be something? Yeah. So there's this inaccuracy around 1 ml with the way I was taught, with the way many people are taught, and we'll get to the university side too in a moment. But this 1 ml inaccuracy stems from the fact that everyone's trying to reach it. We're condensing the soil or compost, or we're dissolving the soil in water into down to 1 ml for compacting it, or we're dissolving it and displacing up to 1 ml. So the problem with that is how structured is your sample? Like, how much structure does that soil have? So if it's like, like sand, right? You're not going to have much air. And so it's going to condense very, very easily. But if you have something that is an aggregate, is Johnson Sue, and you can see, the moisture is making it clay, and it prevents it from really, but we need that moisture, don't we? So let's say we did it without moisture. You dried it down, you baked the soil, you granulated it. You can see all the dust, the fine dust, which is like clinging to the sides like static electricity, right? And you're like, "Oh, Matt, you did it. You did it. You figured it out." Look at the side there, my friend. Do you see those breaks? Yeah, there's pockets you cannot get out because of the way these things structure. It's like taking a thing of Legos, shaking them up, and then holding it. And then you're like, oh, well, there's all these gaps in between the Legos because they're all different sizes and they don't perfectly Tetris together. Right. So subsoil and compacted soils are dense, but they're also finer. And they compact, they are dense, they don't have air in the same way. And this is why they become anaerobic so often. Uh, well-structured soils have lots of air, up to over 50%, sometimes 60% air. And then we compact it into like roughly 1 ml. And obviously, if you go just the line with all that air, it's less than 1 ml. So you're compacting it. Now you're seeing the problem, right? So each sampling represents a different size space from the original soil. It represents a different volume of space. So if you take that volume of space and it's super loamy, you compact it down to this small, tiny thing. You take a space of just sand and dense subsoil, and it's not going to compact into anything. It is what it is. Hmm. So whenever we're comparing like the dead, soil with like bacteria levels, blah blah blah, and then we're talking about the loamy, the numbers with the way that I was taught and the way that most people are taught. Well, unless you're taught by me, you know, they don't work. So, and then how hard are you tamping, right? Some people are like the master tampers and they're like, king, king, and they're like getting more air out than the other person. Not perfectly. No one's perfect. Can't get it all out unless you're displacing with water, but that actually makes it even more efficiently at, skewing it. So a lot of people are taught add 1 ml. And by the way, adding 1 ml to water, like in little bits, good luck trying to be accurate unless you've like granulated it and broken it down and potentially dried it and all this stuff. I like seeing how things are. I like to let nature speak to me. And so doing that, doesn't appeal to me. And so the reality is how structured a soil is determines how much of the soil profile volume you are measuring. And hopefully I demonstrated that well today. Weighing the soil also skews it. So universities are like, no, 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 we're going to bake the soil at 120 degrees for the next 12 hours. And then and then it's like hydrophobic, dry, dead. And now we'll count the life. It's like, what are you talking about? Now you count the life? Ah, and then they're like, they're weighing a gram out. But different soils are different weight. Different soils the gram of weight, depending on which soil type you're talking about, represents a totally different volume of soil. Again, a pseudo standardization is in effect here. So this is a problem. And so moisture content, soil structure, all of this skews this. So we can't trust the numbers. If we do it from multiplication and we're multiplying it up to an acre, it doesn't do that. Though people have been trained in that way. And what's people have discovered, as we'll talk about over the course of this webinar series, different students of mine, different peers of mine have discovered that that way of doing it is misleading, and they have been caught in the crossfires between, inaccuracies that have affected their businesses, affected their practice, and their reputation. So I'm telling you right now that you can't trust the numbers that way. So you need to recognize it's not a perfect ml. It's not, like a perfect gram either. That 1 ml, they say it's like equal to a gram. It's not really true at all. Diluting 1 ml sample to 1 to 100 only increases the discrepancies when you're doing this. So all the numbers that they're doing It's only close enough for very basic generalizations with the caveat that, what you're doing is manufacturing and exaggerating the errors. So the numbers are going to be off every time, but for completely different reasons. So if it's numbers we use, we have to take all of the numbers into account. And that's why, I mean, people find this so difficult because there's too many variables that we cannot accurately measure. So what I decided was go completely around this whole problem. I don't rely on those metrics. I show people how they can get them so they can prove this to themselves. But we look at ratios, just like they do in all the other laboratories and all the other sciences. They're not counting all the sharks in the bay in San Francisco and then all the fish. They're not capturing them all. No, they're taking a sampling and doing ratios, just like the wolves to the elk ratio and all that. That's all we're doing here. Classic. And then we look to the cycles because it's so important. People don't recognize that it's figure out where you are in the cycles is so key to understanding your full context. What's coming next? What's happening? What are the reactions at play? What's missing? And so where are we in those cycles? And I don't just mean like, those visuals. I mean quite well defined down to the pH and EH. There is a place we are in the cycle. And just like here, do you see how the nitrogen cycle plays out over EH and pH? So you can see where you are, right? So everything is always in mid cycle in nature and in life. And we gotta go with it. You gotta roll with it. You gotta take part in it. You gotta partner with the pattern at work, or that, jump rope's gonna hit you in the face. But we have to stay in the frame of reference. That's why the multiplication, the scaling up from a drop to an acre doesn't work. It's just one aspect on a whole picture as well. We have to have the organic matter, the bacteria, the fungi, the protozoa, the nematodes, microarthropods, and worms, as well as the nitrogen, the phosphorus, the salinity, the biomass, the fungal to bacterial ratio, the pH, and potentially if you the EH. But it's not just those kinds of tests, because then you could go down to the micronutrients, the trace minerals, all those kinds of things. But it's also more generalized. Is it compost? Is it soil? What climate are we in? What's the sand to clay to silt ratio? What's the pH? Is this from a specific site or soil over time? Is it related to a plant type? All these questions, they develop a nuance, and it can either be noise or the signal guiding us to greater understanding and better application. So we have to be sensitive to it. We have to take the time. We must document accurately and compare across those differences. But there's more. But wait, who am I? Well, I'm Matt Powers. I appreciate you guys being here with me today. I was a ski racer in New England. What's wild is like Zach Weiss was a skier in New England. You know, Todd Harrington was too. It's just so funny how many of us come from this world. And then also Zach Weiss was a musician. I just learned yesterday in an interview with him. So many of us were also musicians. I was a professional musician after I got knee surgery and stopped being able to ski race. And I played with some incredible people. And in that process, in that time period, I met my wife. And shortly after we were married, after we had our first son, she got cancer and she lost her thyroid. And we did the radiation and the consequences, almost 20 years later, we're still dealing with. She kept getting cancer after this, but it was that event and all the events afterwards that led to me becoming a teacher because I needed healthcare, you know? And right, I needed healthcare. And the doing bass playing, yeah, was fun, but it didn't give me the protection and safety net I needed for my family. And so I became a teacher. And this whole time during this process, my wife kept getting cancer. I kept trying different things, and we raised our boys out in the foothills of California, just below Yosemite in the national forest. So my boys grew up just in love with nature, always immersed in nature. And I started gardening and growing food because I realized the only thing I could control to help my wife was the food and the jobs I did so that I could get healthcare, right? And so I just threw myself completely into this because it's not just my wife, it's our boys. You know, their health is impacted by her health history too. And so I my boys grew up this way. They grew up immersed in permaculture and gardening and soil. And I started embedding it into my teaching. I started being having heirloom seeds and food and all this involved with English 10. You know, I was English 10th grade English teacher for the local high school. And I became head of the English department and I just started getting really into heirloom seeds and I wrote curriculum for permaculture when there was no curriculum for kids for permaculture. And in 1 month, I made almost as much money as I made an entire year after taxes as a teacher in California. Now you can see why they struggle to get good teachers in California. Yeah. Yeah. And so this curriculum exploded. This was a miracle. It was wild. And this all happened in the span of a month. And then it started going all over the world, started being translated in different languages, started working with people, wonderful people from all over the world, had all these incredible mentors, and I became a public speaker, started helping different organizations. My children grew up, and they're still growing up. Uh, James is, doing music and doing jujitsu. Oliver's doing art, and they're both into music. But James has got, his seventh album came out this past week. So in this wonderful journey, this incredible gift of a life that I just am so grateful for every day, I have been able to go from being a musician to a teacher to now author, educator, entrepreneur, soil expert, seed farmer, and family guy, and a citizen scientist. And my mentors, the person who taught me my original PDC, now recommends the regenerative soil microscopy. One of the co-creators of permaculture itself recommends regenerative soil and uses it as his primary source for working with soil. So it's been a real full circle journey for me. It's been absolutely incredible. Um, Jeff Lowenfeld's huge inspiration for me. Again, someone recommending my work. He says with my books you can learn about the microbes. With this book you can see them. So unbelievable. I love you, Jeff. And Jeff is a primary inspiration. Why do you think I'm creating a trilogy? Right, that guy right there. So all of this has really been about building a bridge to the regenerative future. I was never like trying to displace anyone or replace anyone. I was trying to create the curriculum that built the bridge from education so our children and youth can get the skills that are marketable for the regenerative economy so that we can have a regenerative future powered by a regenerative economy. And so that's why I do things standard based, That's why I do things so that professional educators, high schools, universities, all of them can use it. That's why I cite everything. That's why I do everything the way I do it. And I just know that if we don't have these pieces, we don't get to that future. And I didn't, still to this day, there aren't people doing this work. And so that's why I do it. So, what else, Matt? That's great. We got your introduction, but tell us what else are problems that you're finding in microscopy and what are the solutions? So, this is a question that people often struggle with. Can you manually count bacteria accurately? Now, there's always the question of like, do you need glasses? Because someone who needs glasses versus someone who doesn't with really good vision the person with better vision is going to see more, right? Um, It is also the case that, when some of these microscopy folk get, a party and go out at night and they drink, they'll come back the next day and won't be able to see the bacteria because their vision is blurry. So we can we can have lifestyle choices that actually affect our ability to see these things. Now, regardless of whether you can see them or not, are the ones you can see an accurate count of what's there. Well, with a light microscopy, it's important to recognize that there is a limit. You can't see all the bacteria. You can see the largest viruses, the gyruses, the giant viruses, but they're incredibly rare, right? And so you're really missing the bacteria. And different studies, it's really ranges up to 50 to 70% that you can't see bacteria wise. So counting, we can't see all the bacteria. But you're like machines, AI, let's go. They can't accurately either because it's a resolution thing. So you can get closer, but won't stop. After 1,000x, it just blurs. So you can get closer, but it just gets blurrier. It doesn't sharpen after 1,000x. So so you can't count them accurately. And if you look here at the small dots, um, yeah, do you guys see how things are coming in and out? They're traveling by, they're blowing up as like just like the pool effect where you drop something in a pool and it goes down and it gets bigger. You have those things distorting the sizes of them. And then when it's a really, really fine dot, that's it in focus. And so they're swimming in and out of range. And and so just counting is like, wait, is this one that's swimming now over here? Is this one I was just looking at? Went out of range, now it came back. So it's gonna swim in and out of range. There are also things that are too small to see. The highest resolution you can go 1,000x. The sharper you go, like a 4K, that's what this is. You begin to see that it's all teasing and teaming right there at the edges of our vision. So how can this be fixed, Matt? That seems like a fundamental problem. It's like the ratios thing was very elegant. I get that, but how are you going to fix this? DNA, right? DNA. That's expensive, man. And Stephen Russell's working. My Coda Labs is working on lowering the price. Thank you, thank you. And we're all eagerly watching him combine the Lumina with the nanopore, whole genome sequencing. Just amazing. But that's expensive. And we want to help farmers now and not have them buy more, like too much more equipment. We want to keep things as simple and streamlined as possible. And getting them into DNA testing, I don't think is the right step. Maybe, oh, there's a whole thing to this. So it's flat. So it just reads everyone who's there. It doesn't tell you what they're doing, their behavior. And then it depends on the type of test you do. So are you testing for their epigenetic expression? Are you testing for who's there? Are you right? You know, are you testing for all the fungi? If so, you're going to have to target those sections unless you're doing full reads. So it gets really, really complicated very quickly and more expensive. But what if you stained the samples? The dye would be absorbed even by the invisible fungi. So when we do a side by side, this is a method I've come up with. These are videos and they're slices of hemocytometer, which are a fixed grid slide that's standardized across all laboratories. Now, once we put on the stain, you see like this huge color difference. Whoops. Here, let me, yeah. You see this huge color difference. That road one on the far left is my example. The Brute has life in it, but Wiggle and Harris, they have much less life in it. And so the road is the worm castings for my dirt road. It's the guiding example. So shouldn't your worm castings that you have in your compost be as rich microbially as the worm castings from the natural worms in your dirt road? The answer is heck yeah, they should be. In fact, you're giving them much more than you get in a dirt road in terms of food wise and diversity of food wise, that you should see more. But those bagged composts, they're bagged worm composting from Home Depot. And look, just look. Look for the wiggling life. And you're like, oh, I see a lot of little wiggling life in the road, and you see none in these. And then you're like, let's use the dye to verify. I see some wiggling in Brute. But then you're like, okay, the dye has been absorbed completely by the road because it's completely absorbed by the biology. Now, Wiggle has the least life. Harris has a little bit more. Brute has significantly more than both of them, but has nothing compared to the road. Nothing. So, what does that mean? That literally means that you can stain and see the amount of life there by the amount of color. So you got a ton of color there, you don't have much life. But the darker it is, the more the dye is absorbed by the actual life, the more life you have. So the darker it is, the better. And I was doing a stain to just see the life and count by going down to that individual square and counting the living bacteria. And then I discovered this. So, in trying to make a more accurate live dead test stain for soil microscopy, which is what this originally is, and is still this is part of that procedure, but you're doing both. You're able to do both by stacking these. And so I want you to know these things are possible. I want you to know we built workarounds. So what if we rely upon a combination of all these metrics? Because the reality is every test method has a percentage of inaccuracy. So I do holistic testing. I want a 360-degree view through the tests rather than a single side, a two-dimensional understanding. So we just need to take everything with grains of salt and do as many tests as we can, right? And I have a base minimum amount of tests. I have a base minimum amount of things that we need to do, of course. But but if you've got the budget and you're working with some large clients, then do the DNA testing too. Do the things that are expensive that you can't do at the home scale, garden scale. Absolutely, because they will give you a greater 360-degree view. We got to recontextualize. We got to think about that bigger picture. We got to take those steps back to think holistically and see past these limitations that are baked into the education of university scientists and all the other soil microscopy students that have been trained before my program. But this sounds complicated, Matt. Well, we got to embrace complexity and we do it through simplicity. I'm telling you, this is how, the lady I was talking to yesterday at South by Southwest, she was talking about how she's making all these things happen with biology, but all she's doing is working with gray water and earthworks. And I'm saying, like, that's the exact move. We need to move with clarity and power so that we foment life's complexity to beget, protect, and iterate more life. Because that's where we generate complexity, we generate stability and resilience. So embrace it because you can. Because regenerative soil is not just one of these aspects. It's not just soil biology, it's the minerals, it's the organic matter, it's the plant roots, it's the water and air. So our evaluation ratios combined with standardized fungal to bacteria ratio and biomass seen through the regenerative lens, plus all the other tests we talked about, your Haney test, your salinity test, your pH, these are all going to feed into it. And it's going to turn into how we interpret in the actions we take. And it's all seen through the regenerative lens, which is that. That's the regenerative lens because this keeps things clear. So we have tests for each of these, and we have understanding for the way each of these works, and we can diagnose each of these by looking at the cycles and patterns and see where we are with ours or our clients. So many people ask, isn't Brightfield enough? I've got this $200 microscope, Matt. Isn't it enough? Can't I get by with this, Matt? Come on. This is the quite often. Saprophytes are great for composting, right? You can see those. But we can't see the relevant fungi to plants unless we have more. So the mycorrhizal fungi, the endophytes, we need to step up our protocols to actually see those things. And the reality is, without this, you're losing 30 to 40% of the yield that's potential. You're missing out on drought tolerance. You're missing out on, heavy metal remediation and protection and buffering. And this is the other half of your plants. They literally are symbiotic and evolve with plants in their roots. So if you're lacking this, you're lacking the plant's full potential. So focusing on the microbes the plants rely upon most equals more effective decision making. because they're so fundamental. You can be doing all this extra stuff on top treating symptoms without treating the actual problem. The actual fundamental lack is never touched. And meanwhile, you're trying to do all the little finer point operations and actions and cycling and provide them the exact form of the nutrient that they need at this time when that's what the microbes do. And they would do it for free, way more effectively, and holistically help everything involved, protecting the plant at the same time so that you don't have to jump in and protect. Yeah. Yeah. So it's more nuanced. It's more open-ended. So you can be innovating, discovering, and it's more observant. You're going to see it. You're going to be in touch, and because of that, you're going to be more insightful and more confident and more sure of yourself in your practice. Now, as you've noticed, just microscopy is not enough, but we can't fully evaluate and understand our soils, compost, plants, and fungi and roots without microscopy. You can't do the DNA testing and then get back the information you get from microscopy. Think about this. We look at a drop at a time or a root at a time. With DNA testing, we do fractions of a fractions of a fractions of a drop. And so and it is so wild how much life there is in that fraction, but it's also just misses the functionality, misses the interaction, misses the actual context for interaction and where these things play out. And also, if you have been to any of my talks where I talk about horizontal gene transfer, you know that during, you know, even just looking at the microscope under the light, they're doing horizontal gene transfer and exchanging genes in response to their environment and adapting, changing their actual genes. So over the course of a day or two of attacking the bacteria and fungi in the soil, you know, to create, because you have to break them up to break the DNA up to look at the DNA. So you're caustically like attacking this stuff, and the microbe's going to respond, you know, especially because it's milliseconds. They're constantly responding. So I suspect that true reads like nanopore where you know they're getting rid of PCR, pulling that part out. That's a important step, but there's still more development. The truest read we get is the fresh soil, fresh compost, just a little bit of water, get it on the slide and look at it, or just the fresh root, not washed, not stained. It's that immediacy, that intimacy, you know? I mean, you're keeping things alive. You're checking out how they actually work. You're getting in there, seeing it for real. So, so without microscopy, nothing, none of these things actually find their proper grounding. And we can't practice soil microscopy accurately without going beyond bright field because we're so limited. So we got this color, you know, comparison. We've also got mycorrhizal fungi. We've got the live dead test staining. We've got also the ability to see algae because algae are endophytic. That's why, you know, our friends over at End Soil, you know, it's green because it's chlorella. You know, they are doing algae. Right. Yeah. Small world after all. So we can see those things. They show up as blood red and they're immediately identifiable with this. You just flip it on, it's like bloop. So again, we to go to the next level of definitiveness of I mean, if you're doing work for clients, if you're doing lab work, you can't know these things with Brightfield. All the things I've talked about, all the imagine if you didn't know any of this. Imagine the problems that get baked into your practice, your recommendations, your soil. So we're going to fix all that. All right. In this webinar today, we've only scratched the surface. So what if you learned all the microscopy methods, right? Bright field, dark field, manual lighting, and epifluorescence. You confidently test and evaluate your soil and compost with a microscope from home now. You consistently verify that your methods are beneficial. You help others evaluate and understand their soil, their biofertilizers, and their compost, and probably their roots as well. You're part of a community of citizen scientists focused on soil, water, fungi, and compost. Maybe you're part of the Our Soil database. You can do this. I know you can. Learn more at regenerativesoilscience.com. Please share this presentation. Please share this webinar series so we can spread the word and help more people. And if you want to learn more, join us for the live Q&A that's about to happen and the giveaways that are about to happen. We got some amazing things here. See, I have the shirts this time. I We're ready. And join us next week because we're going to be doing getting started with soil microscopy. We're going over all the things that you need, all the basics, all the things to get you started and get you going so you can master the basics and really understand the value of all these things and why there's so much buzz around this. So thank you for being here. I'm Matt Powers, grow abundantly, learn daily, and live regeneratively. All right. You guys ready? Guys ready for what's next? All right. So how was that? Let me know down in the comments. All right. Thank you for being there. I see some thumbs up. Hey, Mamali. Good to see you, my friend. It's been a minute, 2 years, my friend. Good to see you. Yeah. Folks, John says great stuff. Dr. Yvette says great, thank you. Josie says inspiring. Jack says makes good sense. Yeah. Because the reality is when someone teaches you things that go into your good sense, into your common sense, into your the rational logic of nature, you begin to really incorporate that into everything. You begin to see it and apply it into everything in your life. So what happens is I teach students how to understand and think like this, and then they start discovering things, start innovating things. Like for instance, uh, effective microbes, EM, right? So so this right here, I always talk about all this, right? This is selected endophytes. But did you know that the cerevisiae yeast, the Saccharomyces cerevisiae, that that's for arbuscular mycorrhizal fungi. So this encourages mycorrhizal fungi, but arbuscular, not ecto. So one of my students discovered in one of our Q&As, we were going back and forth, and they were looking things up while we were talking, and they discovered that lager yeast is a cave yeast from more alpine regions, and it partners with trees and ecto. And I'm like, that means there is a version of something like this, a biofertilizer, in other words, it's a biofertilizer, that uses the lager yeast and is designed for perennials and trees and the alpine forestry. And that's just one of the amazing things. And then you like Marc Lefebvre, like discovering like how to take manual lighting to a whole new level, and then videoing, clear nematodes like slithering on the surface of compost. To this day, I've never seen anyone else with footage like that. And these are my students. As Zach Weiss and I talked about yesterday, the evidence of real education is when your students go beyond the teacher. And I have consistently seen my students pioneer out and innovate and go further because they have that understanding, they have that insight and that lens. And that's really what it's about. It's about opening that door, and that's why, we're doing the database, the Our Soil database, because we can't presume. We got to let nature tell us. And the way to do that is let it iterate out, replicate things out, let it all play out. Let us see those test answers. Let's compare those test answers and let farmers and everyone else see before and after with the actions in the middle so that they can be like, well, this action led to this result. I'm now going to do that action. and then that becomes viral. And then suddenly, you have entire industries, viticulture, cannabis, ranching, corn farmers, wheat farmers, all these different industries are going viral with their best practices within their community. And it's just simply about connecting those feedback loops in ways that are clear, that are honest, that are growth oriented, so that people, their whole self, that it's not just an aspect, it's that whole self can show up. So I am so excited for that database. We've got an incredible team working on it. I am just always blown away by the levels that they're going to, and I'm really excited about what comes next. Lager yeast, as an Lager, Janice. Yes, yes. There's this beer called lager. Thank you for being here. All right, so here we go. I've got two different kinds of books. I've got t-shirts. Uh, we've got goodie bags. We got the whole shebang, you know? So I hope that you're excited. Hope that you're ready to compete with each other. I don't do the first thing. I used to do like the first question. Yeah, everyone's like, but I read through them, and I always select it now just upon what feels right. So for Regenerative Soil Microscopy, the $80 book. No other book like this. This is an incredible gift, an incredible open door to a completely new understanding of soil. I'm going to be giving it away. All right. So what's one new thing that you guys learned today? Jacob said you're able to tell how much biology is alive by the amount of stain absorbed. Yeah, because it only DNA and RNA are absorbed by that stain, but it has to be alive. Yes. Janice says, "Is in beer yeast. Can one use beer mash left over from breweries in compost?" Absolutely. The staining method. Yeah, I had no idea you were a musician. Yeah, I always warn people. I'm like, you can find my album on iTunes, but you're gonna find like emo Matt, and you're gonna be like, I'm not like eyeliner, but I'm all like emo, like I was 23 once, right? Right? We were all, it was 20 years ago, but it was there. So yeah, I mean, the name of the album is so emo. It's Never Ending Aftermath. Oh, Matt. Oh, Matt. I know. So dramatic. It's hilarious. And then meanwhile, like after like doing all that for like almost 10 years, being like feeling like a hotshot, my own son just is so much better than me. So like now that I think about it and like play with him when I play with him every once in a while, I'm like, Matt, you thought you were good. No. Eh, new methods available, says Josie. Oh yeah. Kathy says to remove preconceived notions and use all resources to paint a better and more whole picture. Yeah, Kathy. Yeah, thank you for being here. Well said. Jan says air pockets compaction. Testing Sue's samples will not be comparable to Ted's. Yes, Jan. All right, Jan, I want to send you this. So email me at mattpowerssoil@gmail.com. mattpowerssoil @gmail.com. mattpowerssoil@gmail.com. I'm going to send you this. Ryan says lifestyle determines your ability to see the microbes. I know, right? It's so funny. Andy says, I learned I need a good microscope. Well, Andy, I'm going to send you a book so that it will help motivate you to get a better microscope. So email me at mattpowersoil@gmail.com. All right. Two $80 books going out. Now, now, what's one new action you're going to take after today? What's something that you learned that you're going to stop doing? That's an action too, isn't it? Maybe you're going to stop doing something. Maybe you're going to start doing something. What is that? for a t-shirt, just like mine. All right. And and so I always say microbes are primary, and as they are, right? This is rhizophagy, mycorrhizal fungi, and rhizobia. So these are key key indicators of of plant health, especially if you're like looking at legumes, right? With the rhizobia. I'm gonna stop drinking the night before doing microscopy work. So thank you for being here. Oh my gosh. So funny. Not to drink the evening before using my microscope. This is amazing. Oh man. This is awesome. This is awesome. Yes, the importance of ratios. Look at my soil and understand how to support it. Yes, Laura. Looking forward to playing around with some logger mash. Yeah, yeah, Angie. Angie, I want to send you a t-shirt. How about that? I'm going to send you a t-shirt. Thank you for being here. Matt Powers Soil at gmail.com. I'm going to send you a t-shirt. But that's not all. I'm telling you, I went the full like whole hog. Like we are ready. All right. So that's what I was wondering about, says Jack. Okay. Thank you for being here, Jack. We have alumni here. We have students here that are part of several programs. Jack is one of them. Thank you for being here. You are awesome. Josie got her 10-year-old son a good microscope for his birthday. He is so excited to be able to see living things. Josie, you're in the UK. Can I send you this for him? Yeah, Josie. It's a large. He'll grow into it, but let's send it to him. Yeah, let's do it. Message me at mattpowersoil at gmail.com. Let's get this young microscopist recognized and honored. Let's do it. Wow, awesome. And we're not done yet. We're not done yet. What is your aspiration with soil microscopy? Like, what do you aspire to do? I aspire to teach everyone I can how to help themselves and others get into closer feedback with the natural cycles and patterns and realities of their soil or their clients' soils, such that they can make better decisions that have better results because they have a clear understanding of how they can partner with those patterns and cycles at work. That's what I'm doing. And so the all these things I'm giving out are to help facilitate that and help you facilitate your journey. And because the soil is the raw potential. Like that's what it really is. So the raw potential of your farm, your ranch, your indoor grow, your garden, your even your balcony garden, all of it comes back to the soil. And yeah, our all civilization's dependent upon it. So you're writing in the comments. I'm going to read those, but first I'm gonna tell you what's in this. So we of course got the classic Kim Tech wipes. Got to keep things clean. We've got exemplary compost. We've got not good compost because you got to compare. We've got pipettes. We've got we've got the 1 ml tube. We've got the 10 ml tubes. We've got the mycorrhizal inoculant so that you have something that you can see and put on roots and see and verify. We also we also have rhizobia, so you can inoculate and check that took. We got slides and cover slips. But all these things are pretty, inexpensive except for $150 hemocytometer. Yeah. This is legit. And that's the thing is it's like to get something that's hyper professional means that you're getting something that's very accurate at that grid, that very tiny grid. But that's not all. We've got methylene blue. We've got pH strip paper. So you're going to be able to, with this kit, get started and start looking and start inoculating and start verifying so that this can become your practice at home, on the farm, or at your business. So here, I'm going to start reading now. Jacob says to bring greater overall health to the community by educating about soil and how all plant needs nutrients and microbes that may be missing, how we can fix it in a regenerative manner. Thank you for being here, Jacob. I love it. Josh says, okay. I want to inspire students to get interested in soil health and how it relates to their own health and happiness, says Crystal. Thank you for being here. We want to share your curriculum with students in Lockhart. I'll send you a message. Ah, thank you, Crystal. That'd be amazing. And to teach this to my 6 kids so we can be empowered to heal the world. Oh, yeah. That's amazing. I have Matt's Regenerative Soil Book and its recipe, which is an inexpensive biofertilizer EM equivalent. Yeah, and yeah, absolutely. And I also have more videos I'm going to be doing soon that'll be public to everyone that'll have new recipes for making EM that are easier. And because I've just been doing recipes, and practicing and refining and innovating because my students are too. So there's been this great, incredible feedback within the community. So I have new recipes and new ways of understanding to create things that are more reliable, more verifiable. So in other words, let me just talk specifically. So with the biofertilizer mix, I would do water kefir, not kombucha, but specifically water kefir because it has such a great variety of lactic acid bacteria and yeast. And then I would use PNS Bio, ProBio PNS. It's you can find it on Algae Barn, and it's a pure culture of purple non-sulfur bacteria, Rhodocytomonas palustris, which is the key element that is always at such a low level in all these brews that people make. So I added it in manually every time I extend. So that's what I mean. Because I've been doing the DNA testing and verifying through multiple extensions what stays, what changes, and what's best. The water kefir with purple non-sulfur bacteria is the new recipe that I'll be modeling soon on YouTube. So keep an eye out for that. It'll eventually be released in the third edition of the book, maybe next year. But for now, I'm doing a YouTube video, and that'll be also doubled in the course. So, but it'll be open so you guys can all see it. Thank you for being here. To verify our compost and AMF and be able to share, educate, and advise everyone that will listen, says Ryan. Ryan, you're going to be a bulwark for change in your area. I'm really excited for it. Diana says, share this knowledge with farmers in Nigeria. Heading there this April for a program kickoff on Earth Day. Yeah. Scarecrow says, I just drank some methylene blue earlier. All right, Scarecrow. Well, don't drink this methylene blue. This is not like the human grade stuff, okay? This is for just microscopy, but message me at mattpowersoil@gmail.com because you just won it. All right. You're not alone. Yeah, yeah. Many of us know the power of methylene blue. I love it. I'm not recommending anything, not a doctor, not doing any of that. But yeah, I honor you, Scarecrow. Thank you for being here. Message me at Matt Powers Music. I mean, Matt Powers Soil at gmail.com. Matt Powers Music is like almost like AOL days, like old. So funny. I thank you guys for being here. Have you ever used bricks on plant leaves in terms of their health of your soil? Um, so yeah, no, I definitely have a bricks meter right here. Um, so bricks is an older technology. It's about 150 years old, and there is a lot of emerging meters and different spectrometers that are about to hit that are so much better. And the only limitation they have right now is they've only mapped out certain plants, and they are the plants that are the commodities. So like wheat, corn, melons, tomatoes. You know what I mean? Like they've done, and as I'm like, I did corn and melons. You know what I mean? And so there's certain things I could get value from that from right now, but it's only a matter of time. They're going to get all the foods. They're going to have all the nuance, and they're going to have all the data, and then we're going to be able to go, deet, deet, I'm not eating that. Deet, deet, this is the one. And the moms are going to be able to do it for the children at the grocery store. And when they do that, that the thing is, it's like, do you guys know Zen Honeycutt? Zen Honeycutt's an old friend of mine. She's the head of Moms Across America, and uh, she's a force to be reckoned with. And her whole thing is moms are a force to be reckoned with. And she rallies the moms together, and they find, glyphosate in the organic bread or in the organic cereals, and they lobby and they make change happen and hold people accountable. So I love Zen, and those moms are going to make these devices, not this particular device. I'm talking about John Kemp's device that's going to be coming out. I'm talking about Olivia Husson's partner Sensine that they're going to be coming out. Those moms are going to use those devices and go, doot, 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 doot. Nope. Doot, doot. And they're going to catalog everything. And we're going to have lawsuits and people pushing back and people demanding clean food. And it's going to just be the greatest opportunity ever for all of us because we're the ones that can verify these things from the soil on up. We're the ones that can remediate these things and verify that they're remediated. And we can see it in the plant, we can see it in the soil, we can see it all the way through. And we've got a huge amount of work ahead of us. So many of us, like going back to the beginning of today, so many of us know things that we should do, but we aren't doing them. Our society is that way too. And we need to raise the imperative, raise the demand. And when we do, it's going to just all self-reinforce. The testing, the results, they're going to reinforce the demand for regenerative soil, the demand for regenerative ag, regenerative beef, regenerative, you name it. And this is not going to be quick. This is going to be over a decade, maybe 2 decades of change. And it's going to be thrilling. It's going to be deeply meaningful. It's going to be a time that new leaders and heroes emerge. And I know that the database, the RSoil database, is one of those catalysts for this change. So I'm really excited. Is this a school kit? No, no, that right there is just a microscopy kit. Um, I did post earlier about regenerative soil, the teacher's guide. And do I have that in here? I don't. But I do have a teacher's guide that goes along with the regenerative soil, and you can use regenerative soil microscopy in tandem with that. And so you could have like a 2 year science elective with what I have created at a high school level. So I definitely have the curriculum. It's separate. The kit's just for the microscopy. All right. Thank you for being here. And so Q&A. What questions do you guys have? Where do you get epifluorescence lamp? From LW Scientific. So this is an LED light. Everyone else is using mercury halide, and they're more expensive. So this beautiful unit, um, it it's safe to have at home. And you can buy it from LW Scientific. Obviously, if you're just going to buy it without a discount, it's going to be more money. My students have a 37% discount, and this month, my students have a 40% discount on the whole setup. So you can get the power, it's called the power, they named it after me, the power package. You can get the whole thing yourself, and you can get it 40% off when you sign up at regenerativesoilmicroscopy.com. But yeah, unless you have a like a Zeiss or a more expensive microscope than this, it won't, like, this unit won't work on them. You need to contact LW Scientific to find out if you have a microscope that can handle this. It's about distance. And so the Zeiss microscopes, the more like a $15,000 microscope instead of this one that's like 4,000, that's going to get you there, right? But that's the thing. It's like we're talking about four times less the cost of what most people are paying to get the same thing. So it's an incredible discount. It's an incredible machine and offer that they've created for the world. And it's the first. And because I figured out how to use it while it was still new, and I've been able to create all these methods and do all these different things and showcase it. But it's because it's new, and it's new in terms of it being LED, but not new in terms of epifluorescence, because epifluorescence is pretty old. So I have all the science, I have all the data, but now we can use it for the first time. So it's incredible. It's an incredible breakthrough. It's something that was waiting to happen. You know, when Dr. Elaine Ingham wrote about how we can use epifluorescence to verify mycorrhizal fungi in 1981, she was using a toxic microscope. So we've come a long way, and it's wild that it never was solidified until now. But working with mycologists, working with scientists all over the world, we've been able to do it. So, yeah, I'm really really grateful to my mentors and all the support that they've been able to give me. Does the soil work offset chemtrail poison? My woods are very stressed from all the poison. Well, let's define that, Laura. So, if it's chemtrails, it's probably aluminum, right? You're talking about aluminum, right? So aluminum toxicity is the main topic of one of the subsections of our podcast interview earlier this week with Todd Harrington. He is remediating soils with aluminum levels of 40,000 parts per million. That's like unheard of. It's probably the worst example other than like a Superfund site. And he's remediating it with Ray Archuleta. So all the information from that is going to trickle down and we're going to be able to apply it everywhere because he also has a soil test showing that aluminum levels have gone up like skyrocketed in the past 30 years all over North America. So he has the data and he also has a solution. And we all kind of know what that is. It's regenerative. It's working with the microbes and it's not just compost tea. When this comes out on Friday, you guys are going to freak out because Todd is like the best. So Todd is feeding minerals to the compost to mineralize it to specifically fill in the gaps of the mineral side of things. He's also putting the right plants in there to create the exudates to cue the succession and to cue it to match whatever plants he's going to be doing. And so he is literally cueing the compost in a way before he even uses it, testing it and verifying it, and then using it. And because of that, I mean, this is why he works on, 1.5 million acre projects, right? And so it's phenomenal what is possible with deep understanding of soil biology, microscopy, soil testing, and and compost. And like I just for many of you, you probably are like, wait. You're adding plants? Yeah, it's part of the curing process. We talk about it in the podcast. It'll be out on Friday. Um, but all these things are fixable. All these things are fixable. And Todd has been behind the scenes doing all this work for a long time, 30 years. And when we met 2 years ago, within 10 minutes, he like leaned in and goes, I do ratios too. And we became super friends after that. he, he was like, Matt, your book is amazing. I've been doing it. He was like, and I did never stop to make a book because I've just been doing it at a commercial level, bake, and yeah. And so it's just been amazing to get that kind of verification from someone who's been doing it commercially for decades and had came to the same conclusions about ratios as I did. And so, we started a series. The first one is this Friday. We're going to be doing a series of these podcasts with Todd on all the incredible projects that he's done. What would be a better way to manage a mass amount of brush from pruning or removals instead of burning it all? Turning it into a biochar, doing a conservation burn, or chipping it and adding it on top of your orchards or your perennial areas as a mulch cover. So either or, and maybe a little bit of both, so that you have a mixture of biochar and woody mulch to go over your because they do different things, right? So yeah, I would do that. Does this so okay? What would be some of the first things you would do for soil if you bought a 12-acre farm with not much knowledge of its background? Well, I would test. I would 100% test because the chances are it was managed a certain way, and you'll be able to see that, and then you'll be able to treat that and remediate that, and you'll also be able to see the strengths and weaknesses beyond damage. So I would do testing. I would do biological, mineral, all the forms of regenerative soil microscopy, holistic testing, and then I would let it speak to me. I would let it tell me what would go best there, because many people have their ideas and they try to force the landscape to adhere to their vision, and it can do that sort of, and to a degree. But if you're like, no, 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 I want to grow, you know, dwarf bananas. You're in Oregon, far from the coast, and it's like that's not going to work, right? But of course, you could like do a giant greenhouses and expend all this money and do all this stuff to create all this artificial environment, and then you can, right? But farmers are going to do the least amount of disturbance possible and the least amount of energy expended because they've got to scale it up. So they have to be extremely pragmatic. So I would stick to seeing what the landscape tells you and then make a decision from there. And the replay of this will be out on Friday, so look for it. Or no, replay for you guys will be out Thursday. I'm gonna release it early for you guys. And then I'll release a partial replay on YouTube on Friday. When trying to DIY bioremediation of plastics, what methods do you recommend? I'm going to be using EM biochar in lab while trying to introduce some different fungi species as well to see what happens. Wish me luck. Yeah, so this is the thing. Um, you have to be really careful because it has been proven from multiple sources in multiple tests from around the world that microplastics promote human pathogenic gene expression in the fungi that eats them. It's a little bit like karma. The pathogenic fungi is growing, and we've got an increase in fungal pathogenicity incidences in humans in the past 10 years. I don't know if you've noticed, but people are fighting fungal problems internally way more than they were when I was a kid. And a huge part of it is the fact that there's microplastics in them and all throughout their environment. And the thing that remediates that quite often is things like Aspergillus fumigatus, which causes aspergillosis. I've had a student who composts with a dog that died of aspergillosis. In the UK, there are instances of people who died who are compost company workers. So they're working with hot compost with it gassing off and releasing those microbes in the air, and they're breathing it and getting it on themselves and in themselves. And so we really have to be smart. Johnson Sue is so great because you're not in there turning it, getting covered with those microbes. Pit composting is great because it's all happening underground. You put a cap on there, and you could put tubes in it, chimneys and stuff too. But this whole idea of remediating microplastics, it must be done, but we got to do it carefully. We have to keep our thinking caps on. This is also why I publish what I publish. So much of my work is like, maybe wear a mask when you're turning your compost pile. Maybe don't smell your compost. Like, have you noticed people do this? Uh-oh, for real. I mean, I find like, Narcoidioides, like the 12th most common microbe that I find in soil and in compost, not good. Not good. So you have to be very careful about a lot of these things. And so that's why I teach the way I teach. And that's why I encourage everybody look it up, see for yourself. And that's why I go to the original source materials. We read from, you know, originals, the books, stuff like Berge's Systematic Bacteriology. These books are so expensive. Um, books like books like this one, which is now $1,000. I bought it at $100, folks. I didn't buy it at 1,000, but and so I've got and we refer to these books. I show you inside these books, so you get a glimpse into the value that's in them. Because some of these books, the value is that those 3 pages I just showed you. Don't buy the book for $400 because the rest of the book doesn't matter, right? I went through the bath for you. Don't go through the bath now. Um, and so I teach to everybody from the original source materials, and then what we do is we go verify it because it only matters if you can verify it. If it's just information, that's the noise we've been talking about, not signal. So I'm only concerned with signal, verifiable things that you can do and track their effects. Because otherwise, we're hoping, you know. I appreciate you guys being here so much. This was so much fun. This is just week. This is just the first one. This is just week one. Next week we're gonna be meeting twice. I kind of condensed the schedule. I had a bunch of things come up, so I was like, we're gonna do it all next week. So next Tuesday and Friday, not Wednesday, not Wednesday after that. Next week we're doing it twice. So I hope you join us 1 o'clock Tuesday, 1 o'clock Central, 11 o'clock Pacific, and then on Friday 4 p.m. Central, 2 p.m. Pacific. So I hope you join us for that. We'll keep doing good giveaways. You'll win. I know you'll win. People win. I go out to events. I see people wearing the shirts. I see people on the Zooms. You guys win. You guys. So I'm excited to give out more things. Thank you for being here, being part of this community. I'm Matt Powers. Grow abundantly, learn daily, and live regeneratively. I'll talk to you guys soon. Have a great week.